Hello and welcome. My name is Megan Van Emmen, and I'm an Extension Beef Cattle Specialist with Montana State University. Today I'll be presenting a few slides on developing some cow rations, what information we need, and how to calculate least cost rations without utilizing a ration formulation program. We're going to focus on mature cows for this portion. However, some other things that we might need to know if I'm talking to a producer or an extension agent when I'm developing these rations, whether using a ration formulation program or just doing it by hand calculations. First being the class of cattle we will be developing this ration for. For this purpose, we will be using mature cows. However, we can be looking at developing heifers, first calf heifers, as we're getting towards calving season or we're already in calving season currently. How long we're going to be feeding those animals for, what is their current body weight and body condition. These are especially important if we have some thinner cows out there as we're moving into the calving period or post-calving, or even if we're in mid-gestation and we've just weaned and we need to add some body weight and condition back to our animals. Where are they reproductively? Are we looking at pre-calving, post-calving, mid-gestation, etc.? How big will that calf be? The weight gain goes into the body weight analysis as well. Or if we're looking at those developing heifers or our first calf heifers that are still growing and we're asking them to gain weight and produce a calf as well. If we're looking at developing heifers, at what age will we be breeding those? I put environment last on here because we can make some environmental adjustments as we develop these rations, which I'll basically provide a slide towards the end, how we would adjust those factors. However, I have not taken those into account as I did some hand calculations with the rations. But first and foremost, after that is, what do you want to feed? Are we feeding hay? Are we feeding some alternative feeds or grains? What supplements do you have out there for your cattle? Whether that's lick tubs, lick blocks, cake, things like that. And then kind of a big one is nutrient analysis, which will be covered in a different webinar. But that's the way we can get the most accurate picture for these cattle as we develop rations, is to have an accurate analysis that's been conducted strictly from your feed ingredients. So always recommend getting a nutrient analysis completed on those feed ingredients. And this is especially important, for our hays that we're going to be utilizing, because not everyone's hay is the same, and looks can be extremely deceiving as we look at those rations, and that's mainly due to the environment that they were raised in. In 2019 over the summer, it was very cool summer, a lot of rained on hay, and although that hay may look good, we may not have the best quality. And then on here is also vitamins and minerals. Now, I a lot of times don't take these into account as I formulate rations. As long as you have a vitamin and mineral program, whether that's a loose mineral or through a lick tub or lick block of any sort like that, just because there's so many different variations out there, to be adding that into a ration formulation program can become a little challenging. However, I can include it as I need to, but I typically calculate those separately, just because of the inclusion factor and not necessarily knowing how much of the block or mineral, loose mineral, that those animals are consuming. So if we look at these nutrient requirements of our mature cows, this is a 1,400-pound cow, which is about our average body weight across the United States right now. And just looking, these numbers come directly from Oklahoma State University. They have a very good extension publication for cow, heifer, and bull requirements, putting everything on pounds per head per day basis, and looking at post-calving, mid-gestation, pre-calving. They also include if you're going to have some weight gain on those animals, as well as approximately how much dry matter intake they'll be consuming. So if we're just looking at these requirements here, focusing right now on the pre-calving and post-calving. So pre-calving, we're getting towards the end of that season this year, as we are towards the end of March. But just looking here, roughly 14.5 pounds of TDN, or total digestible nutrients, or energy per head per day, and then a little over 2 pounds of protein required every day during the pre-calving period. So that's that last probably 60 to 90 days prior to calving, when that calf is growing exponentially in that uterus, and they're putting a huge demand on those cow requirements. Now, if we look at post-calving, which a lot of our livestock producers are in right now, once again, energy and protein are increasing. Even compared to our pre-calving, this is our most highly demanding time frame for our cows each year, just due to not only the calving process and uterine involution as she prepares to breed again, but also due to that lactational demand that she now has to provide that milk for the calf. And then as we look into mid-gestation, this is typically around our weaning time, and in the fall for our spring calvers, where requirements are at their lowest for her yearly interval. And this is mainly due because lactation has ceased, and fetus is not extremely large and not putting a lot of demand on those cows. So the main ones I'm going to focus on for this presentation are the TDN, or total digestible nutrients, and protein factors, just because those are two big factors we need to make sure we're hitting to keep up the fetal growth during pre-calving, and then that lactational demand in post-calving, and make sure those calves are developing correctly in utero, as well as good milk quality for that calf growth post-calving. So if we look at our mature pasture, crude protein and energy, I put this on here just to give producers an idea of what those cows are actually consuming each day. And the big one is, if you have your cows out on pasture, basically especially in Montana, from about August, September timeframe all the way through winter and into even early spring right now, towards late March, that mature grass is not very high quality. So just to give a couple rough estimates here, we're looking at about a 5% crude protein and 50% TDN, or energy, from that pasture that they would be grazing. So roughly, to give an idea, right about now, especially in that pre-calving time scenario, she should most likely be consuming about 2% of her body weight on a dry matter basis every day. So to get how much that would be, you would take your cow body weight, multiply it by the 2% as a decimal, or 0.02, and that gives us 28 pounds of dry matter intake, or DMI, every day. So this time of year, this becomes rather limiting, just because we're moving into that calving season, and intake does start to become limiting because of that fetal growth, and the forage itself is rather bulky, very stemmy, and she cannot take in as much as we would expect her to, with a lush green forage. So right now, forage may be limiting out on the pasture, even though it appears there might be quite a bit available. Just keep that in mind, that she's not going to be able to consume as much due to rumen limitations. So if we look at our 5% crude protein for our pasture, so to figure out how many pounds of protein she would consume each day, that's 28 pounds of that dry matter we calculated previously, times 5% as a decimal, 0.05, which gives us 1.4 pounds of protein. We do the same thing for our energy, so 28 pounds times 0.5 gives us 14 pounds of energy. Now, if we start thinking back to that previous slide of where those requirements were sitting, and we're going to look at pre-calving first. So she required 2.1 pounds of protein each day. So we just subtract 1.4 from 2.1, and we get that she is short on protein by about 0.7 pounds. We do the similar equation with our energy, and she is short about half a pound of energy. Now that's pre-calving. So let's say, as I know, a lot of livestock producers currently are moving into that post-calving phase, and requirements are going to start to peak. Looking at, she needed 3.5 pounds of protein, so we're shorting her, if we're just asking her to graze, 2.1 pounds of protein. If we're looking at the energy factor, we're shorting her about 6.5 pounds of energy during that post-calving phase. So we can start looking at different supplements, whether it's the hay or other grain source or something like that, to how to help meet these requirements while our animals are out grazing. So if we're going to feed a hay, how much are we going to need of that hay to meet those requirements? So if we focus right now on that left column on pre-calving, on the top portion, we're looking at crude protein. So you can do this with any sort of feed ingredient you need to help make up that shortfall of the energy or protein requirements. So basically, we're going to solve for X. So if we start at X pounds of the feed, in this case hay, multiplied by the protein of that feed as a decimal. So for this it was a 12.9% protein hay. So we would multiply X by 0.129. And then we're solving for the 0.7 pounds of protein that she was short consuming that pasture. So if we solve for X, basically we divide 0.7 by 0.129, and we get 5.4 pounds of hay would be needed to make the crude protein up. We do the same equation with total digestible nutrients. In this case, that hay was 54.6% TDN. We again solve for X in the same manner as the crude protein, and we end up with 0.9 pounds of hay needed to meet those TDN requirements. Now, because there's a difference and we require more hay to meet the protein, we should focus on that protein amount of hay needed to meet those requirements and not the TDN. We will just be overfeeding for the energy requirements to make up that shortfall of the protein. Now, if we look at post-calving and feeding that same hay, we're going to do the exact same equations. As we can see on the right column, we need quite a bit more hay, about 10 pounds more hay to meet those requirements during post-calving than we did during pre-calving. The same can be seen with the TDN number as well, and that's just that increased demand of that calf for that lactation. So if we think about it that way, we figured out how much hay we need. So as we move into our cost per unit of nutrient basis, we're looking at hay here, as well as an additional supplement. So if we focus on utilizing our protein and our energy, that 12.9% and 54.6% energy from the previous slide, we can calculate how many pounds of crude protein and energy are in each ton of hay. So if we pay $120 per ton for that hay, we multiply 2,000 pounds times crude protein as a decimal, so 0.129, which gives us 258 pounds of protein in 1 ton of hay. To get the price per pound of nutrient, we basically just take the cost we paid per ton, divide it by the pounds per ton of that nutrient, so $120 divided by 258 pounds of protein, which gives us 47 cents per pound of protein for that hay. We do the same with our energy, and we get 11 cents per pound of energy. Now, if we look at our supplement, this cost is just a made-up cost that I used, as well as this isn't indicative of any sort of supplement. This is just to give you an idea of how to calculate everything. Now, the one thing to keep in mind is that most feeds, especially your commercial supplements, cakes, lick tubs, things like that, do not provide you with a TDN number. I tend to estimate them about 60 to 65% TDN, depending on the ingredients that are included. The only way to know that for sure is some companies may provide that number for you, or you could collect a sample and send it in for nutrient analysis, and you can get that accurate number. So we're going to do the exact same thing with the supplement here. So this one is a 20% protein, 60% TDN supplement. So gives us about 400 pounds of protein. When we divide $300 by the 400 pounds of protein, we get 75 cents per pound of crude protein. And we do the same with the TDN, and we get 25 cents per pound of TDN. So that's our cost per nutrient basis. The big question is how much do we need to feed of these to make up that shortfall in the protein or energy that we're trying to supplement for? So we calculated the hay previously. So if we look strictly at the supplement, we do the exact same equations and solve for X, and we need 3.5 pounds of supplement to meet the protein needs. So if we look at the cost per head during pre-calving, and we had to feed that hay at 5.4 pounds per head per day to make up that shortfall of 0.7 pounds. We follow those equations that we previously saw. Very similar here. We have the 0.7 pounds of protein that we're providing with that hay, multiplied by the price per pound of nutrient, which gives us 33 cents per head per day for the hay to make up that 0.7 pound deficit. Like I said, we're going to overfeed on energy because that wasn't our limiting nutrient as extensive as protein was, but that's going to be about 32 cents per head per day. Now, if we look at our supplement, we needed to feed 3.5 pounds per head per day to make up that shortfall of 0.7 pounds. So we multiply by the 0.7 pounds by the 75 cents per pound of protein, and that gets us to 53 cents per head per day. Or for energy, which we were going to overfeed, was 42 cents per head per day. Now, this is just one example. This does not mean that hay is always better than a commercial supplement, but also don't underestimate the power of a good quality hay for a supplement to meet those protein and energy needs if it is more cost effective or less labor intensive than your commercial supplements. So this is why we break everything down on a cost per nutrient basis, and then we can figure out how much we need to feed each day of each supplement or each other feed ingredient, and we can get a more accurate price estimate of what that is going to cost us on a daily basis per head. So just in this scenario, we have hay that would probably be more cost effective just on the hay portion, not necessarily on labor or equipment costs or things like that. So those other things need to be taken into account. Plus, there are other supplements out there, commercial supplements that are much cheaper than $300 a ton that can provide similar amounts or of protein or things like that. So it's just sitting down with a pencil and paper and doing the math and figuring out which one would be most cost effective for your operation. So previously I mentioned those environment adjustments because I did not take those into account for the cost per nutrient basis or the requirements. So that is something to keep in mind that we may adjust for. One thing to keep in mind is that the rule of thumb is that for every degree below 32 degrees Fahrenheit, we increase energy requirements by 1%. This chart is from the NRC. For beef cattle, when we start adding in, different temperatures and weather conditions, we can alter those requirements. However, this year, with the mild winter, some of the state received, not all of the state, but some of the state, requirements weren't as drastically increased as they could have been, especially the last couple of winters where we saw, minus 20, 30, and 40 for months on end. So um, that's just something to keep in mind, and making sure those cows can stay in good body condition during the winter months as we move into the calving season. So with that, I'm Megan Van Emmen, Extension Beef Cattle Specialist with Montana State University. I thank you for listening, and please let me know if you have any questions.